Was all right. So this is gonna be our fifth one. Shit, we should probably have it 7 in this one. 8. I don't know. We got a few. This is a big section. This is the big one. How the hell we do shit? What we're gonna do for the rest of this? Well, not really the rest. Real important. Let's go. So we're gonna look at this, explore this idea. But first, I wanted to finish up a limit from the last one. So I'm going to run this one through real quick. This is going to be something you're going to see a lot in 2.7 and 2.8. And let's go get this thing. So the game we have here is we have a 0 over 0 case. Since we have this square up top, it's telling us just, hey, maybe try expanding that shit out. Huh? Maybe try expanding that thing out. Maybe some algebra might happen. And this one actually falls out very quickly, but I just want you to see it because I know sometimes just calling it h instead of x can jack our brain up. I know notation was one of the hardest things for me as a student. I didn't like functions. I didn't like anytime you change it from an x, it pissed me off. So I'm going to try and create you to be better than me. I'm going to try and use, which isn't too hard to be better than me, but using a little different notation, but the h is always going to be there. In calculus, h is important. Okay, babbling on. Let's go. So let's expand that thing out and see what happens. So this one actually ends up being a pretty straightforward problem. 4 plus h all squared. I'll tell you what it doesn't equal. 4 plus h all squared, what it doesn't equal will never equal, only unless h equals 0, but it does not equal 4 squared plus h squared. Get over that shit. If that's how algebra worked, you would have already been done with calculus. Algebra would be the easiest shit ever. But when you have 4 plus h all squared, that means write that shit twice. It equals this. 4 plus h times 4 plus h, and then remember foiling? First outer, inner, last. Let's go. Excuse me. Okay, so when you expand out 4 plus h times 4 plus h, it ends up becoming h squared plus 8h plus 16. That's what 4 plus h all squared equals. And then you got the minus 16 on the outside, all over the h. And how convenient. How freaking convenient. Huh? Look at those 16s go away. Factor out the h and we're ready to go. This is what we call a gimme. This is a gimme in the algebra. Oh, I'm sorry. Did I say algebra? Did I say algebra? I meant calculus. Calculus is all freaking algebra if you haven't noticed already. We're just writing the word limit and then plugging it in instead at the end after we do some canceling. Now plug in 0 for h. Our domain issue's gone. And it just equals 8. Yeah, dude. Huh? Let's go. Let's go. All right. Let's get into it. Our concept. Here it is. We want to take a look at this. The limit as x tends towards 0 of x over the absolute value of x. Or it's the same thing. Well, it is the same thing, but it's not. I'm going to stop there. I was going to try and get tricky, but yeah. Let's graph this thing and take a look at what x over the absolute value of x is. Because we're going to use this concept. It's not going to be x and just the absolute value of x. It'll be like x minus 4, and then the absolute value of x minus 4 will be what we'll start looking at. So let's look at this. Let's look at the graph. Because do you know the definition of the absolute value of x? Do you know the definition? Did you know the absolute value of x is actually just a piecewise function where it equals x if the values are positive or 0? You know what I mean? What's the absolute value of 4? 4, because 4 is positive. Okay, and it's equal to negative x if x is less than 0. Because what's the absolute value of negative 3? It's 3, right? So don't you have to change the sign of negative 3 to positive 3? That's what it's saying. There's the definition of the absolute value. It's x. It's just itself when that shit's positive. And don't you have to change the sign when it's negative? That's what it's saying. So to graph x over the absolute value of x, it's actually just like this. There's the graph. At -1 and +1. Let's plug in some values so I can prove it to you. If we plug in +1, Don't we get 1 over the absolute value of 1? Isn't that just 1? Okay, let's plug in 2 and see what happens. So isn't that going to be 2 over the absolute value of 2? What's the absolute value of 2? That's 2, right? So that equals 2 over 2, which equals 1. All right, cool. I'm pretty sure if you plug in any positive value, you're going to find out that shit is going to equal positive 1. Now let's play that same game, but let's use different values. Let's go with the negatives. Let's look at -1. Right down here. So let's plug in x equals -1. Let's see what happens. Let's look at f -1. Let's plug it in. So we get -1 up top, and then we get the absolute value of -1 down below. So that's -1 over +1. So what's -1 over +1? That's -1. Now do that with 2. Oh, let me change it. 2, 2, 2, 2. Oh, still frickin' -1. Oh shit, I made a mistake. That was 21. Oh shit, it still equals -1. There's the gain. Now we have a limit from the left and we have a limit from the right. Do you see that on our graph? The limit from the right points to 1. The limit on the left points to -1. Therefore, the limit does not exist. When you see this absolute value, you're going to start thinking, shit, it's only going to be limits from the left or limits from the right. Those are the only ones that are going to exist. This is going to be one of the trickiest problems in your homework. You're going to have something like this that you're going to need to be able to think through. And I'm going to test you on it. You got to understand this concept of the absolute value of x on the bottom. And some of my best students in the math center working with me for hours, frustrated and mad. It takes them a while to understand this concept. So if you get it right away, dope. If you don't, you're right there with everybody else. So let me write one more, and I just want to graph. Now this is algebra. This is just straight algebra. I'm not doing anything. I mean, it's probably more algebra than you've seen before. But let's take the absolute value of x minus 7 all over x minus 7. We'll call this g of x. Now I want to just graph it up. Just want to graph that thing up. Now where would be our domain issue for this one? Where would be a domain issue? 7, right? 7 would be bad. So when we go to graph this, our domain issue, remember back here? Where was our domain issue in this one? When we had our x over the absolute value of x. Wasn't it at 0? Because you're not allowed to plug in 0 into the denominator. So you had right there was the issue. Well, now it's going to be at 7 is going to be where those meet. So let's say that this is 7 right there. All right, cool. There's 7. We're going to graph it up. So at -1 and +1. If we graph it, we're going to find out if you plug in 7, that's bad. There's a hole there. But anything bigger than 7, you're going to find out is equal to 1. Anything smaller than 7, wow. Like my graphing? It's pretty good, huh? It goes to -1. All right, plug in 6. See what happens. A number smaller than 7. You get 6 minus 7 inside of an absolute value over 6 minus 7. That's the absolute value of -1 over -1, which is equal to frickin' -1. You choose a number bigger than 7, it's going to equal to that. Is a big concept. That is a big concept. So the limit as x tends towards 7 from the left-hand side of that g of x, well, that's equal to -1. And the limit as x tends towards 7 of that g of x, well, that's equal to +1. I'm telling you, you're going to need this concept in order to do your problems for your homework and again on your exam. You will see it. You'll know it when you get to it. Absolute values in calculus means take pause. Don't try and do algebra. Look at the problem. Absolute values. Wow. Are not your friend anymore. Remember that back in algebra? You're like, I love absolute values. What's the absolute value of -8? You're like, 8. I love this shit. No longer. They are not your friends. This means no algebra. It means look. Take a look. Peek at it. Look at the graph. Don't do algebra. And don't you dare just cancel out absolute values. That is going to be the trick I'm going to try and set you up for. Please, I'm begging you, don't cancel out absolute values. Don't just do one of these. Because that's not true. All right. I'm done babbling. See you in the next one.